is going to show how to solve a system of equations by graphing, but by looking at a table of coordinates or a table of values instead of looking at the graph itself. So in order to do this, you do have to have your equations into slope-intercept form. Since we're doing two linear equations, we want them in slope-intercept form, which is y equals mx plus b. On this first example, both equations are already set into slope-intercept form, so we can go ahead and go straight into our calculator to do this. Now to look at this in the calculator, we will go to the y equals button on the calculator, and then we're just going to type in the first one into y sub 1. So we're going to type in the negative, make sure that's the negative and not the minus, 3x plus 4. And then for the second equation, we're going to type that into y sub 2. Just like in Desmos, it would be on the second bar. We're going to type in the 3x minus 2. Now that we have them in our graphing tool, the y equals section, we can actually look at the table of coordinates and see where they intersect. So what I'm going to do is I'm going to look at the table here. It's that blue table. So I'm going to press the second button and then the graph, which is table. Now I can look at the x values, and then these are the y sub 1s and the y sub 2s. So what's happening here is this table represents the first equation, and then the x and the y sub 2 represents the coordinates for the second equation. As you can see, the y-intercept for the first one should be 0, 4, and that is what the y-intercept is for the y sub 1. And for the y sub 2, our y-intercept should be 0, -2, and we have 0, -2. So this is how we look at that. These first two columns are for the first equation, and then you take your x, which is your independent variable, and your y sub 2, and that's your table for your second equation. But we can look at them all together at the same time to make it a little bit easier on us to see everything. So what we want to do is scroll up and down on the x variable to see where the y sub 1 and the y sub 2 have the same value. Now, it's not whether or not they have the same number as the x. It's all about, does the y sub 1 and the y sub 2 match the same? And hopefully you can see at 1, 1 is for y sub 1, and also 1, 1 for y sub 2. Since they both have the same y value here, that means that they intersect at 1 for the x, 1 for both of the y's. Therefore, the solution to this system of equations is 1, 1. And it did not matter that it was the 1 here on the x. What really mattered was, are the y's matching each other? So if we look down at this second problem, which is a little more complicated because they are not in slope-intercept form. So we'll do this one, and then you'll see how it looks on the graph as well. I'm going to go back to my y equals. I'm going to clear both of these out. I'm going to come back over to my problem and write out the correct version of this in slope-intercept form. So our first equation, I know I need to subtract that 4x. So I'll have y equals. I'm going to subtract that 4x to both sides, and I'm going to keep that positive 2. Now I have y equals by itself, so that means that this first equation is in slope-intercept form. My second equation, I have to subtract the x from both sides. So I'm going to have negative y is equal to negative x, and then a positive 3. But then because y is not by itself yet, I still have to divide everything by that negative. So when I divide everything by that negative, I'll have a positive y is equal to a positive x, and then a negative 3. So that's my new equation. So my first equation, going back to my calculator, is negative 4x plus 2. Our second equation is y equals x minus 3. And again, I'm not going to look at the graph because I don't want to try to think about where it's happening. I want to be able to look at my table and be able to figure out my answer from my table. So I'm going to press my second graph button, so that's the blue table. I'm going to look to see where are my y values the same. So I'm going to look right now. So I have my y sub 1 and my y sub 2. If I see on my screen as it is, I have 2 and negative 3, not the same. I have negative 2 and negative 2. Those are the same. So therefore my coordinate of intersection is the x value of 1 and then they both have the same y value of negative 2. So my solution is 1, negative 2. That is the solution of these two equations. And if we look at the graph of this, because now that I know my solution, I'll just look at the graph to see what it looks like. I'll just press the graph button. Here's our first equation. Here's our second equation. They are intersecting at this location right here, which is at 1 and negative 2. So this tracks that this is the correct answer. So we do one more example on here. I'm going to go back to my y equals. I'm going to clear out both of my equations so I can start back over. So my first equation here, 4x plus 2y equals 10. So I know we have to subtract the 4x first. So I'm going to have that 2y is equal to a negative 4x, and then we still have a positive 10. But y is not alone yet, so I have to divide everything by 2. So if I divide everything by 2, I'll have y is equal to, so a negative 4 divided by 2 is a negative 2x, and a positive 10 divided by 2 is a positive 5. So there's our first equation. I'll go ahead and type that into my calculator. I have a negative 2x plus 5. So then for our second equation, we have to subtract the x. So I'm going to keep that negative y equals, we'll subtract the x, we have a negative x, and we have a positive 13. Again, I do not have y by itself, so I need to divide everything by that negative 1. And when we do that, we get that positive y is equal to a positive x and then a negative 13. So we have our second equation is y equals x minus 13. So now I'm going to go to I'm not going to look at the graph yet. I want to go straight to my table. So I'm going to press the second and then table. Now I'm going to look on the screen that I have right now to see if any of my y values are the same. So I'm going to I'm going to press the right arrow key so I can move around on here. Now, when I'm in my x's, I can move up and down. But when I'm in the y's, I can't move up any further. I'm pressing the up button and nothing is happening. So when I am in my x's, I can move up and down because the x's are the independent variable. So again, I'm going to check on all my y values that I have right now. So 5 and negative 13, negative 12 and 3, 1 and negative 11, negative 10, negative 1, negative 3, negative 9, negative 8, negative 5, negative 7, negative 7. These have the same y value, therefore this will be my intersection. The intersection is the x value of 6 and the y value of negative 7 because they both have that same exact coordinate. So the answer to this solution, or to this problem, is 6, negative 7. And I can double check that on my graph. So I'll press graph, and this is going to be the first equation. This will be our second equation, and they intersect right here. So if we count, we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So 6, negative 7. So you can see that on a table on the TI calculators by going to second table. You can see the values, the y values are the same. Now what if we did this on Desmos? On Desmos, you still have to have that same setup to where it's y equals. But if I come over into a Desmos screen, I'm going to create a table here. So I'm going to create my own table. And instead of my y sub 1 up here, I'm going to completely delete that. And I'm going to type in that y equation, so that negative 3x plus 4. But I'm not going to put the y in there. I'm going to put negative 3x plus 4. Now you'll see that there is an exclamation point here, a warning sign. It's because my x value, I have to say what x values I'm going to use. I'm going to use my x sub 1 values. Now, whatever I put into my x sub 1, it'll actually do the math for me for the y value. So I can also put in the second equation beside it to make another table. Go back and get the other equation, which is 3x minus 2. I'll type this in here again as 3x minus 2 without the y in there. But again, I still have to use that x sub 1. Now, whenever I type in any coordinates in here, so I'll start at like negative 10, and I'll go down to negative 9, and then I can just press enter, and it follows that pattern. So what I'm doing is I'm watching my y values as I type in these numbers. Now I'm not sure exactly where it's going to go, but on Desmos, I can just keep following that pattern. So I'm going to watch my y values. So these y values are not the same, so I'm going to keep going. I'll keep going, keep going. I'm just pressing enter, and it's still going. Still pressing enter, still pressing enter. And there is where the y values are the same, and that 1, 1. Now on Desmos, I can also make sure that these blue dots, I can hold this down, and I can make it a line. Same with the green. Hold this down, make it a line. And then I can see that they are in fact intersecting at 1, 1. And that's the same thing that I was showing on the TI calculator, where you can go back to the graph and kind of see where it's intersecting at. And on Desmos, you can actually click to see where it's actually intersecting. So the coordinate of intersection, or the solution to the system of equations, is 1, 1. You can do the same thing with these other two that we did as well. But again, you have to have them into the slope-intercept form in order for this to work. So I know that my solutions are 1, -2 for this one. So if I go into my Desmos screen, I will clear out this table. I'll start a new one. So again, I'm going to clear out the y sub 1. I'm going to type in that -4x plus 2, -4x sub 1 plus 2, because I'm using x sub 1 over here. Then I'll press the right arrow key and I'll move over to the next column and I'll put the second equation, just like it is on here. This is x, this is y sub 1, y sub 2. So this is the first equation, second equation. Do the same thing here. X minus 3, so that's x sub 1 minus 3. Now I have my x's, my first equation, my second equation. Now, again, we knew that it was at 1, -2, so I'll actually start it at -3. And then it's doing the math for me right here, and then I'll do -2. And don't forget, you can also count by a half. So I could have just gone to -2.5. And then I can go to -2. And then it'll go to -1.5. So what's happening here is that it's actually counting by halves instead of a whole number, which is nice if you have some weird numbers happening or if your intersection is at a decimal value. So I can keep pressing enter until I get to my answer of the y values here being the same. So these two numbers are not the same. These two 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 are the same. So again, I can hold this down, make it a line. I can hold this blue one down and make it a line, and it actually connects all those coordinates. Then I can see that they will both connect at 1, -2. So in Desmos, you can make them quite easily count by a decimal value. You can do the same thing in a TI calculator. It's a little more complicated. You just have to come up to table set. So second table set. And you can actually tell your calculator to start at a specific value. So if I didn't want it to start at 0, I wanted it to start at -10. You don't have to delete anything. You can just type over it. But then it says delta table. That means the change in table. What is your table counting by your x's? So if I press the down arrow key, I can actually make this count by 2's, or I can make this count by a half. I can make it count by anything I would like to, especially if I have some decimal values going on. Now I have my table starting at -10, and it's going to count by a half. So if I go back to my table, so second table, it starts at -10, and it's counting by a half each time. And then I can see my y values. And again, you cannot click over to the y's and make it move up and down. So even if I just kept pressing down, oh, it does actually move down. It will not move up. I actually did not know that. So there you go. That's something I've learned today. So on the x's, you can move up. But on the y's, you cannot move up any further. You can, however, move down the list using your y values. So I can still look through where are they intersecting at. And it still should be at 6. Same problem that we just had in there is at 6, -7, because I did not change out the equation. So I was just showing how to change the table to where it counts by a half. You can do that quite easily on Desmos by just starting the pattern. on a TI calculator, if you go to table set, that's literally what that says. It's TBLSET, table set. We can set our table to start at whatever we want to, and we can make it count by anything we want to as well. So again, to find the solution of a system of equations from the table of values, you find when you type in both equations, or all of the equations, however many you have, you find in your table where the y values are the same. When the y values are the same, you have your coordinate. You take the x value and the same y value for all of them, and that's your y value of your coordinate. I hope this helps.